Here are 100 facts about galaxies. 1. Galaxies are massive systems of stars, gas, dust, and dark matter bound together by gravity. 2. Our Milky Way galaxy is just one of billions of galaxies in the observable universe. 3. Galaxies come in various shapes, including spiral, elliptical, and irregular. 4. The Andromeda Galaxy is the nearest spiral galaxy to the Milky Way and is expected to collide with it in about 4.5 billion years. 5. The largest known galaxy is IC 1101, which is estimated to contain over 100 trillion stars. 6. Galaxies can be grouped into clusters and superclusters, creating immense cosmic structures. 7. The Virgo supercluster is a massive collection of galaxies that includes the Milky Way. 8. The smallest galaxies are dwarf galaxies, often containing only a few billion stars. 9. Elliptical galaxies are typically older and have less star formation activity than spiral galaxies. 10. Some galaxies emit powerful jets of particles and radiation from their centers, known as active galactic nuclei. 11. The Milky Way is approximately 100,000 light-years in diameter. 12. The Hubble Space Telescope has provided stunning images and data about galaxies. 13. The observable universe contains an estimated 2 trillion galaxies. 14. Galaxies can collide and merge, leading to the formation of larger galaxies. 15. The Milky Way's supermassive black hole, Sagittarius A*, resides at its center. 16. Galaxies rotate, with stars near the center orbiting faster than those at the outskirts. 17. Galaxies contain vast clouds of gas and dust that serve as the raw material for star formation. 18. The Large Magellanic Cloud is a satellite galaxy of the Milky Way visible from the southern hemisphere. 19. Galaxies can have companion galaxies that orbit around them. 20. The shape of a galaxy can reveal information about its history and evolution. 21. Galaxies were formed from the density fluctuations in the early universe. 22. Some galaxies are known for their intricate and beautiful spiral arm patterns. 23. The distance between galaxies can be vast, with millions of light-years separating them. 24. The Triangulum Galaxy is another nearby spiral galaxy. 25. Galaxies emit various types of radiation, including visible light, radio waves, and X-rays. 26. The Coma Cluster is a massive cluster of galaxies located in the constellation Coma Berenices. 27. The Milky Way's galactic halo contains globular clusters and dark matter. 28. The Milky Way's outer regions are home to sparse populations of stars. 29. Galaxies can have extended halos of stars, gas, and dust. 30. The Milky Way is part of a galaxy group that includes the Andromeda Galaxy and the Triangulum Galaxy. 31. The nearest known galaxy to the Milky Way is the Canis Major Dwarf Galaxy. 32. The concept of galaxies as separate entities was proposed by Edwin Hubble in the 1920s. 33. The Sloan Digital Sky Survey has mapped millions of galaxies in the universe. 34. Some galaxies exhibit gravitational lensing, where their mass bends and distorts light from background objects. 35. The Milky Way's spiral arms are not rigid structures but rather regions of higher star density. 36. Galaxies can have different populations of stars, including young, hot stars and older, cooler stars. 37. The Milky Way's rotation curve indicates the presence of dark matter. 38. The Milky Way's galactic center is obscured from view in visible light due to interstellar dust. 39. The Local Group is a small cluster of galaxies that includes the Milky Way and Andromeda. 40. Radio galaxies emit powerful radio waves due to the activity around their supermassive black holes. 41. Active galactic nuclei are often powered by the accretion of matter onto supermassive black holes. 42. The Milky Way's satellite galaxies include the Large and Small Magellanic Clouds. 43. The Milky Way is estimated to contain around 100 billion stars. 44. Some galaxies have massive star-forming regions known as starburst galaxies. 45. the Milky Way is thought to have cannibalized smaller galaxies over its lifetime. 46. Galaxies can be found at different stages of development and evolution. 47. The Milky Way's spiral arms are named Sagittarius, Perseus, Norma, Scutum Centaurus, and Outer Arm. 48. The Great Attractor is a gravitational anomaly affecting the motion of galaxies in our local universe. 49. Quasars are extremely bright and distant active galactic nuclei. 50. The Milky Way is moving toward the Andromeda Galaxy at a speed of about 110 km per second. 51. The Milky Way's halo contains some of the oldest stars in the galaxy. 52. Some galaxies have intricate patterns of dust lanes and star clusters in their spiral arms. 53. Galaxies emit energy across the electromagnetic spectrum, from radio waves to gamma rays. 54. Galaxies in clusters can undergo a process known as galaxy harassment due to gravitational interactions. 55. The Milky Way's rotation takes about 200 million years to complete one full turn. 56. Some galaxies, known as green pea galaxies, appear green due to strong emission lines of oxygen. 57. The Milky Way's galactic disk is home to the majority of its stars and gas. 58. The local void is a vast region of space with few galaxies, surrounding the local group. 59. The Milky Way's spiral arms are not fixed structures, stars move in and out of them over time. 60. The term galaxy originates from the Greek word galaxias, meaning milky circle or Milky Way. 61. The Milky Way's central bar structure is composed of stars, gas, and dust. 62. Some galaxies exhibit rapid star formation rates, producing new stars at an astonishing pace. 63. Galaxies can have satellite galaxies, which are much smaller galaxies that orbit around them. 64. The Milky Way's central bulge contains a dense concentration of stars. 65. Galaxies can have massive halos of dark matter that extend beyond their visible components. 66. The Milky Way's galactic plane is a region of higher star density running across the sky. 67. The cosmic microwave background radiation provides a snapshot of the universe when it was just a few 100,000 years old. 68. The Milky Way's central supermassive black hole has a mass of about 4.3 million times that of the Sun. 69. The Milky Way's spiral arms are not actual physical structures but rather density waves. 70. Galaxies can collide and trigger intense bursts of star formation. 71. The Milky Way's halo contains old globular clusters, which are dense groups of stars. 72. Galaxies can have regions of intense star formation known as stellar nurseries. 73. The local group contains more than 54 galaxies, including dwarf galaxies. 74. The Milky Way's rotation speed is greater near its center and decreases towards its outer regions. 75. The Milky Way's disk is relatively flat and contains spiral arms. 76. The Milky Way's galactic disk is rich in interstellar gas and dust. 77. Galaxies can have complex structures, such as rings, bars, and tidal tails. 78. The Milky Way's disk is surrounded by a spherical region called the galactic halo. 79. Galaxies have been classified into various morphological types based on their appearance. 80. The cosmic web is a large-scale structure of galaxies, connected by filaments of dark matter. 81. Galaxies can interact gravitationally without colliding, leading to tidal distortions. 82. Some galaxies are actively forming stars in their central regions, known as starburst nuclei. 83. The Milky Way's nearest neighbors, the Magellanic Clouds, are visible from the southern hemisphere. 84. Galaxies can have multiple generations of stars, with new stars forming from enriched gas. 85. The Milky Way's rotation curve was instrumental in providing evidence for the existence of dark matter. 86. The Milky Way's spiral arms are composed of a mixture of stars, gas, and dust. 87. The center of the Milky Way is located in the direction of the Sagittarius constellation. 88. Galaxies can emit radio waves due to the presence of charged particles in magnetic fields. 89. The Milky Way's disk is not completely flat but slightly warped. 90. Galaxies can have irregular shapes due to gravitational interactions with other galaxies. 91. The Milky Way's spiral arms are regions of higher star density that wind around its disk. 92. Galaxies can have massive outflows of gas and dust from their central regions. 93. Some galaxies have halos of hot gas that extend far beyond their visible boundaries. 94. The Milky Way's rotation speed is influenced by the distribution of mass within it. 95. Galaxies can be identified by their unique spectral signatures and brightness profiles. 96. The Milky Way's disk is composed of stars of varying ages and chemical compositions. 97. Galaxies can have asymmetrical shapes due to interactions with nearby galaxies. 98. The Milky Way's central bulge contains a mix of old and young stars. 99. Galaxies can exhibit intricate patterns of light and dark in their spiral arms. 100. The study of galaxies provides insights into the evolution and dynamics of the universe. 1. Outer space refers to the vast expanse beyond Earth's atmosphere, where there is a near-vacuum environment. 2. Outer space contains stars, galaxies, planets, moons, asteroids, comets, and various forms of energy and matter. 3. The universe is the entirety of space, time, matter, and energy, including everything that exists. 4. The observable universe is estimated to be about 93 billion light-years in diameter. 5. The first human-made object to reach outer space was the V-2 rocket launched by Nazi Germany in 1944. 6. The boundary of outer space is generally considered to be the Kármán line, located at an altitude of about 100 kilometers, 62 miles, above sea level. 7. The term outer space is often used interchangeably with space or cosmos. 8. Outer space is characterized by extremely low pressure and temperature, making it inhospitable to human life without protective equipment. 9. The temperature in outer space is close to absolute zero, minus 273.15 degrees Celsius or minus 459.67 degrees Fahrenheit. 10. The closest star system to our solar system is Alpha Centauri, located about 4.37 light-years away. 11. The Hubble Space Telescope has provided stunning images of distant galaxies, nebulae, and other cosmic objects. 12. Outer space contains cosmic microwave background radiation, which is leftover radiation from the Big Bang and provides insights into the early universe. 13. The International Space Station, ISS, orbits Earth in outer space and serves as a laboratory for scientific research and international cooperation. 14. Outer space is largely a vacuum, with an average density of about 1 atom per cubic centimeter. 15. The vacuum of outer space means there is no medium for sound to travel, so sound cannot be heard in space. 16. The Sun is located in the Milky Way galaxy, which is just one of billions of galaxies in the observable universe. 17. The concept of space travel has been a subject of human fascination for centuries, inspiring works of science fiction and exploration. 18. Outer space is not completely empty, it contains interstellar gas and dust, as well as dark matter and dark energy. 19. Black holes are regions in outer space with extremely strong gravitational forces that even light cannot escape. 20. Outer space contains cosmic rays, which are high-energy particles originating from sources such as supernovae and other high-energy events. 21. The study of outer space is called astronomy, while the study of the universe's overall structure and properties is called cosmology. 22. The expansion of the universe was discovered in the early 20th century and is a fundamental aspect of cosmology. 23. The concept of a wormhole, a hypothetical tunnel-like structure connecting distant points in space and time, has been explored in theoretical physics. 24. The lack of atmospheric interference in outer space allows for clearer observations of celestial objects and phenomena. 25. The first human to travel to outer space was Yuri Gagarin, a Soviet cosmonaut, who orbited Earth on April 12, 1961. 26. Outer space travel presents numerous challenges, including radiation exposure, microgravity effects, and life support systems. 27. The Cassini-Huygens mission provided valuable insights into Saturn and its moons, including the discovery of liquid water on Enceladus. 28. The Mars rovers, Spirit, Opportunity, Curiosity, and Perseverance, have explored the Martian surface and conducted scientific experiments. 29. The James Webb Space Telescope, JWST, set to launch in December 2021, will be a powerful tool for studying distant galaxies and exoplanets. 30. Outer space contains various types of electromagnetic radiation, including visible light, radio waves, X-rays, and gamma rays. 31. The concept of time dilation, a prediction of Einstein's theory of relativity, means that time passes differently in outer space compared to Earth. 32. The outer space environment poses challenges to human health, including muscle atrophy, bone density loss, and increased radiation exposure. 33. Outer space contains exoplanets, which are planets that orbit stars outside our solar system. 34. The New Horizons mission provided detailed images and data of Pluto and its moons, shedding light on the distant dwarf planet. 35. The concept of a multiverse suggests the existence of multiple universes, each with its own set of physical laws and constants. 36. The Andromeda Galaxy is on a collision course with our Milky Way galaxy, and the two are expected to merge in about 4.5 billion years. 37. Outer space contains pulsars, rapidly rotating neutron stars that emit beams of radiation, appearing as pulsating signals when observed from Earth. 38. The concept of a space elevator involves a structure extending from Earth's surface to space, allowing for easier transportation of materials and people. 39. The cosmic web is a large-scale structure of filaments and voids that connect galaxies across the universe. 40. Outer space is the birthplace of stars, as vast clouds of gas and dust collapse under their own gravity to form new stellar systems. 41. The concept of a Dyson sphere envisions an advanced civilization harnessing the energy of its star by enclosing it with a megastructure. 42. The age of the universe is estimated to be about 13.8 billion years, based on observations of the cosmic microwave background radiation and the expansion rate of the universe. 43. Outer space is home to gamma-ray bursts, extremely energetic explosions that can outshine entire galaxies for a brief period. 44. The concept of terraforming involves transforming the environment of a planet or moon to make it habitable for humans. 45. Outer space contains asteroid belts, such as the one between Mars and Jupiter, where numerous small rocky bodies orbit the Sun. 46. The Drake equation is a formula used to estimate the potential number of extraterrestrial civilizations in the Milky Way galaxy that could communicate with us. 47. The Outer Space Treaty, signed in 1967, aims to promote peaceful use of outer space and prevent the placement of nuclear weapons in space. 48. The concept of panspermia suggests that life on Earth may have originated from microorganisms or organic molecules transported through space on comets or meteoroids. 49. Outer space contains cosmic strings, hypothetical one-dimensional structures that may have formed during the early universe's phase transitions. 50. The Great Attractor is a gravitational anomaly in outer space that influences the motion of galaxies in our local cosmic neighborhood. 51. The concept of a white hole is a theoretical region in spacetime that emits energy, acting as the reverse of a black hole where nothing can escape. 52. The outer limits of the Earth's atmosphere, known as the exosphere, gradually fades into outer space. 53. The concept of the Fermi paradox questions why, given the high probability of extraterrestrial life, we have not yet detected any other civilizations. 54. Outer space contains quasars, incredibly bright and distant galactic cores powered by accretion of matter onto supermassive black holes. 55. The Voyager 1 and 2 spacecraft have traveled beyond our solar system and are now in interstellar space, carrying messages for potential extraterrestrial discoverers. 56. The concept of dark matter suggests the existence of invisible and non-interacting matter that exerts gravitational influence on galaxies and cosmic structures. 57. Outer space contains the Oort cloud, a hypothetical region beyond the orbit of Pluto where comets are thought to originate. 58. The concept of a cosmic microwave background suggests that the universe was once extremely hot and dense, and its residual radiation is detectable as microwave radiation. 59. Outer space contains cosmic voids, vast regions with significantly lower matter density compared to the average. 60. The concept of time travel, a popular topic in science fiction, involves the ability to move backward or forward in time using advanced technology or wormholes. 61. Outer space contains rogue planets, which are free-floating planets that are not gravitationally bound to any star and drift through space. 62. The concept of a quasar's redshift is used to measure the expansion of the universe and calculate distances to distant cosmic objects. 63. Outer space contains magnetars, neutron stars with extremely strong magnetic fields that can generate powerful bursts of X-rays and gamma rays. 64. The concept of cosmic inflation suggests that the universe underwent a rapid expansion phase in its early moments, explaining its large-scale structure. 65. Outer space contains cosmic neutrinos, nearly massless particles that travel close to the speed of light and interact very weakly with matter. 66. The concept of a cosmic string network is theorized to form topological defects in the fabric of spacetime and could have implications for the universe's structure. 67. Outer space contains pulsar planets, exoplanets that orbit pulsars and are subjected to extreme conditions, including intense radiation and gravitational forces. 68. The concept of Hawking radiation suggests that black holes can emit radiation and gradually lose mass over time due to quantum effects near the event horizon. 69. Outer space contains magnetospheres, protective magnetic fields surrounding planets that shield them from the solar wind and cosmic radiation. 70. The concept of a space habitat envisions self-sustaining structures in outer space where humans can live and conduct research for extended periods. 71. Outer space contains the Local Group, a collection of galaxies that includes the Milky Way, Andromeda, and several smaller galaxies. 72. The concept of dark energy suggests the existence of a mysterious force that is driving the accelerated expansion of the universe. 73. Outer space contains the Kuiper Belt, a region beyond Neptune where icy bodies, including Pluto, reside. 74. The concept of cosmic strings could potentially lead to the formation of closed time-like curves, which are pathways that allow for time travel. 75. Outer space contains cosmic voids, which can stretch over hundreds of millions of light-years and contain relatively few galaxies. 76. The concept of a space colony envisions self-sustaining habitats in outer space where humans can establish permanent settlements. 77. Outer space contains supernova remnants, the remnants of massive star explosions that release energy and heavy elements into space. 78. The concept of a parallel universe suggests the existence of separate universes with different physical laws and properties. 79. Outer space contains rogue black holes, which are not bound to any galaxy and move freely through space. 80. The concept of a black hole's event horizon is the boundary beyond which nothing can escape the gravitational pull, not even light. 81. Outer space contains cosmic filaments, long and thread-like structures that connect galaxies in a cosmic web. 82. The concept of a white dwarf is the remnant core of a star after it exhausts its nuclear fuel, characterized by high density and low luminosity. 83. Outer space contains magnetospheres, which play a crucial role in protecting planets from harmful solar wind and radiation. 84. The concept of a cosmic egg is a philosophical metaphor for the universe's origin, suggesting that the universe emerged from a primordial state. 85. Outer space contains the local void, a vast region nearly empty of galaxies that surrounds the local group. 86. The concept of a cosmic firewall is a controversial proposal that challenges our understanding of black hole event horizons. 87. Outer space contains dark nebulae, dense clouds of gas and dust that obscure light from background stars and are often seen silhouetted against brighter regions. 88. The concept of a cosmic lattice suggests that the universe's large-scale structure is characterized by a network of interconnected cosmic strings. 89. Outer space contains the cosmic microwave background radiation, a faint glow of radiation left over from the Big Bang. 90. The concept of a cosmic anthropic principle suggests that the universe's physical constants are fine-tuned to allow for the emergence of intelligent life. 91. Outer space contains galactic superclusters, vast collections of galaxies that are among the largest structures in the universe. 92. The concept of a parallel universe or alternate reality suggests the existence of other universes that may have different laws of physics and conditions. 93. Outer space contains dark galaxies, hypothetical galaxies that are made primarily of dark matter and emit very little light. 94. The concept of a cosmic latte refers to the average color of the universe, a pale beige or off-white color resembling the color of coffee with milk. 95. Outer space contains cosmic fractals, self-similar patterns and structures that repeat at different scales in the universe. 96. The concept of a multiverse proposes that our universe is just one of many universes that exist in a larger cosmic landscape. 97. Outer space contains galactic cannibalism, a process where larger galaxies consume smaller ones through gravitational interactions. 98. The concept of a cosmic landscape suggests that the universe could exist in a multitude of states or configurations, each with its own set of physical laws. 99. Outer space contains exoplanetary atmospheres, which can provide insights into the composition, temperature, and potential habitability of distant worlds. 100. The concept of a cosmic lens involves using the gravitational bending of light by massive objects, such as galaxies, to magnify and study more distant objects behind them. 1. The Sun is a G-type main sequence star. 2. It is located at the center of the solar system. 3. The Sun's diameter is about 109 times that of Earth. 4. The Sun's mass is approximately 333,000 times that of Earth. 5. The Sun's surface temperature is around 5,500 degrees Celsius, 9,932 degrees Fahrenheit. 6. It is composed mainly of hydrogen, about 74%, and helium, about 24%. 7. The Sun's energy is generated through nuclear fusion in its core. 8. The process of fusion converts hydrogen into helium, releasing vast amounts of energy. 9. The Sun emits energy in the form of light and heat. 10. Sunlight takes about 8 minutes and 20 seconds to reach Earth. 11. The Sun is about 4.6 billion years old and roughly halfway through its life cycle. 12. It has a roughly spherical shape, but its rotation causes it to bulge at the equator. 13. The Sun's equatorial rotation period is about 25 days, while its polar rotation is about 35 days. 14. Solar activity, such as sunspots and solar flares, varies in an approximately 11-year cycle. 15. Sunspots are cooler, darker regions on the Sun's surface caused by magnetic activity. 16. Solar flares are bursts of high-energy radiation and particles associated with sunspot activity. 17. The Sun's gravity keeps the planets and other objects in the solar system in orbit around it. 18. The Sun's gravity also plays a role in the motion of comets and asteroids. 19. The Sun's outer atmosphere is called the solar corona, which is much hotter than the surface. 20. The solar wind is a stream of charged particles, mostly electrons and protons, ejected from the Sun's corona. 21. The solar wind interacts with Earth's magnetosphere, causing phenomena like auroras. 22. The Sun's magnetic field is generated by the motion of charged particles in its interior. 23. Solar eclipses occur when the Moon passes between the Earth and the Sun, blocking its light. 24. A total solar eclipse happens when the Moon completely covers the Sun, revealing the solar corona. 25. The Sun's energy output is responsible for Earth's climate and weather patterns. 26. The sun's energy is essential for photosynthesis in plants, which sustains most life on Earth. 27. The sun is used as a navigational reference point by various cultures and civilizations. 28. Ancient cultures often worshipped or revered the sun as a deity. 29. The sun is about 109 times the diameter of Earth and 333,000 times its mass. 30. The sun's energy output is equivalent to about 386 billion megawatts, or 3.8 times 10 to the power of 26 watts. 31. The sun's gravity exerts a force that keeps planets, moons, and other objects in orbit. 32. The sun's core is the region where nuclear fusion occurs, producing immense amounts of energy. 33. The sun's core temperature is around 15 million degrees Celsius, 27 million degrees Fahrenheit. 34. The solar constant is the amount of energy Earth receives from the sun, about 1,361 watts per square meter. 35. The sun's atmosphere consists of several layers, including the photosphere, chromosphere, and corona. 36. The sun is part of a galaxy called the Milky Way. 37. The sun's position in the Milky Way is about 27,000 light-years from the galactic center. 38. The sun orbits around the Milky Way's center, taking roughly 225 to 250 million years to complete one orbit. 39. The sun's apparent path through the sky is called the ecliptic. 40. The sun's gravitational pull affects the orbits of all objects in the solar system. 41. The sun's gravitational force decreases with distance, following an inverse square law. 42. Solar energy is harnessed through solar panels to generate electricity. 43. The sun's energy is also responsible for driving Earth's water cycle, leading to rainfall and weather patterns. 44. The sun's intense heat and radiation prevent other objects in the solar system from becoming stars. 45. The sun's diameter is so large that about 1.3 million Earths could fit inside it. 46. The sun's core is extremely dense, with matter compressed to high pressures and temperatures. 47. The sun's surface is covered in granules, which are small convection cells caused by heat rising from the interior. 48. The sun's corona is visible during a total solar eclipse, appearing as a halo of light around the darkened moon. 49. The sun's core produces neutrinos, subatomic particles that are extremely difficult to detect due to their weak interactions. 50. Solar energy is being increasingly used as a clean and renewable source of power on Earth. 51. The sun's energy output has a direct impact on space weather and can affect satellites and communication systems. 52. The sun's rotation rate varies with latitude, with equatorial regions rotating faster than polar regions. 53. The sun's core is primarily made up of hydrogen nuclei undergoing fusion into helium. 54. The sun's energy is a result of the mass-energy equivalence described by Einstein's famous equation, E equals mc squared. 55. The sun's immense gravity causes it to hold the entire solar system together. 56. Solar prominences are loops of plasma rising above the sun's surface, often seen during solar eclipses. 57. The sun's magnetic field can become twisted and distorted, leading to solar flares and coronal mass ejections. 58. Solar storms caused by solar flares and coronal mass ejections can disrupt power grids, communication, and navigation systems on Earth. 59. The sun's solar wind extends far beyond the orbit of Pluto, forming the heliosphere. 60. The sun's energy output has been relatively stable over the past few centuries, with minor variations. 61. The sun is gradually increasing in brightness over its lifetime, which will eventually affect Earth's habitability. 62. The sun's energy output is gradually increasing due to the accumulation of helium in its core. 63. The sun will eventually exhaust its hydrogen fuel and expand into a red giant, swallowing inner planets like Mercury and Venus. 64. After becoming a red giant, the sun will shed its outer layers, forming a beautiful but brief planetary nebula. 65. The sun will ultimately collapse and cool, becoming a white dwarf, a dense, Earth-sized remnant. 66. The Sun's gravitational influence helps to keep the solar system's planets, asteroids, and comets in relatively stable orbits. 67. The Sun's magnetic field can flip its polarity over time, roughly every 11 years during the solar activity cycle. 68. The Sun's ultraviolet radiation is absorbed by Earth's ozone layer, protecting life from harmful effects. 69. Sunspots are temporary phenomena on the Sun's surface, caused by strong magnetic activity. 70. The Sun's gravity causes a small but measurable tug on the planets, causing them to wobble slightly in their orbits. 71. The Sun's energy travels through space in the form of electromagnetic radiation, including visible light, infrared, and ultraviolet. 72. The Sun's core is so dense that a teaspoon of its material would weigh millions of tons on Earth. 73. The Sun's core is under immense pressure, equivalent to about 340 billion times Earth's atmospheric pressure. 74. The Sun's energy radiates outward from its core through a process called radiative diffusion. 75. The Sun's magnetic field lines create loops and arcs that are visible during solar eclipses and with specialized instruments. 76. The Sun's rotation rate is fastest at the equator and slower at higher latitudes, causing the equator to bulge slightly. 77. The Sun's temperature increases with distance from its core, reaching over 1,000,000 degrees Celsius in the corona. 78. The Sun's energy output fluctuates slightly over an 11-year solar cycle, known as the solar activity cycle. 79. Solar observatories, both ground-based and in space, closely study the Sun's behavior and phenomena. 80. The Sun's magnetic field plays a crucial role in the dynamics of its outer layers and solar phenomena. 81. The Sun's magnetic activity can lead to the ejection of charged particles into space, causing geomagnetic storms on Earth. 82. The Sun's powerful magnetic fields are generated by the movement of charged particles in its interior. 83. The Sun's energy output is so vast that it is estimated to be sufficient to meet Earth's energy needs for millions of years. 84. Solar telescopes allow scientists to observe the Sun's surface, prominences, and other features in detail. 85. The Sun's energy supports all life on Earth and is the driving force behind Earth's climate and atmospheric circulation. 86. The Sun is not the largest star in the universe, some stars are much larger and more massive. 87. The Sun's gravitational pull keeps the planets in relatively stable elliptical orbits around it. 88. The Sun's position in the Milky Way galaxy influences the motion of nearby stars and objects in the galaxy. 89. The Sun's energy output is gradually increasing over geological timescales, affecting Earth's long-term climate. 90. The Sun's surface appears mottled due to convection currents carrying heat from the interior to the surface. 91. The Sun's magnetic activity is closely linked to its 11-year sunspot cycle. 92. The Sun's gravitational influence extends throughout the solar system, shaping its structure and dynamics. 93. The Sun's energy drives the water cycle, leading to the formation of clouds, rainfall, and other weather patterns on Earth. 94. The Sun's core is under such high pressure that hydrogen atoms are compressed into a dense plasma. 95. Solar scientists use instruments like spectrographs and magnetometers to study the Sun's properties and behavior. 96. The Sun's powerful magnetic fields can cause loops and eruptions of plasma that extend far above its surface. 97. The Sun's energy is a critical component of Earth's climate system and plays a role in regulating temperatures. 98. The Sun's magnetic activity is driven by the complex interactions between plasma and magnetic fields in its interior. 99. Solar activity can have significant impacts on technology, including communication satellites and power grids on Earth. 100. The Sun's immense energy output and gravitational influence shape the dynamics of the entire solar system and the universe beyond. 1. The Moon is Earth's only natural satellite. 2. It is about 1/6 the size of Earth. 3. The Moon is approximately 238,855 miles, 384,400 kilometers, away from Earth on average. 4. The moon has a diameter of about 3,474 kilometers, 2,159 miles. 5. Its gravity is about 1/6th that of Earth's. 6. The moon's surface area is about 14.6 million square miles, 37.9 million square kilometers. 7. The moon's rotation period is about 27.3 days, which is also its orbital period around Earth. 8. The moon always shows the same face, called the near side, to Earth due to synchronous rotation. 9. The far side of the moon, also known as the dark side, is the side that faces away from Earth. 10. The moon has been visited by humans during the Apollo missions, with the first landing occurring on July 20, 1969. 11. Neil Armstrong and Edwin Buzz Aldrin were the first humans to walk on the moon during the Apollo 11 mission. 12. The moon is covered in impact craters, caused by collisions with asteroids and comets over billions of years. 13. The moon has no atmosphere, which means it has no weather or significant protection from space radiation. 14. The moon's lack of atmosphere also means there is no sound in the traditional sense, as sound requires a medium like air to travel through. 15. The moon's surface temperature varies greatly, from extremely cold, -173 degrees Celsius, in shadowed areas to very hot, 127 degrees Celsius, in direct sunlight. 16. The moon has mountains, valleys, and vast flat plains called maria, singular, mare, which are made of solidified lava. 17. Lunar maria are named after the Latin word for seas because early astronomers mistakenly believed they were large bodies of water. 18. The moon's largest impact crater is called the South Pole Aitken Basin and is about 1,550 miles, 2,500 kilometers, in diameter. 19. The moon's craters vary in size, from tiny pits to large basins. 20. The moon's gravitational influence causes tides on Earth. 21. A lunar eclipse occurs when the Earth passes between the Sun and the Moon, causing the Earth's shadow to be cast on the Moon's surface. 22. A solar eclipse happens when the Moon passes between the Sun and Earth, blocking out the Sun's light. 23. The Moon's color appears white or gray from Earth due to the way sunlight is scattered and refracted by the lunar surface. 24. The Moon's surface is covered with fine dust called regolith, created by billions of years of meteoroid impacts. 25. The Moon has a very thin exosphere, which consists of trace amounts of hydrogen, helium, neon, and other gases. 26. The Moon's lack of atmosphere makes it unable to support life as we know it. 27. The Moon's size and distance make it appear almost the same size as the Sun during a total solar eclipse, leading to the phenomenon known as the corona effect. 28. The Moon's gravitational pull causes Earth's axis to wobble slightly, leading to changes in the tilt of the planet over long periods. 29. The Moon's crust is thinner on the near side compared to the far side. 30. The Moon's lack of atmosphere means there is no protection from micrometeoroids, leading to constant impacts on its surface. 31. The Moon has moonquakes caused by the gravitational interactions with Earth and the cooling and contracting of the lunar interior. 32. The Moon's surface reflects sunlight, making it visible from Earth as a bright object in the night sky. 33. The Moon's ancient surface contains rocks that are billions of years old, providing valuable insights into the early solar system. 34. The Moon's soil, or regolith, contains small amounts of various elements, including oxygen and helium-3, which could be of interest for future lunar resource utilization. 35. The Moon has been a subject of fascination and inspiration for cultures and civilizations throughout history. 36. The Moon has been associated with myths, folklore, and religious beliefs in different cultures. 37. The Moon's phases, caused by its changing position relative to the Sun and Earth, are known as the lunar cycle. 38. The Moon has 8 distinct phases: new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, and waning crescent. 39. The Moon has been used as a navigational tool by sailors and explorers for centuries. 40. The moon's brightness is measured in terms of its apparent magnitude, which varies depending on its phase and distance from Earth. 41. The moon's surface has been visited by robotic spacecraft from various countries, including the United States, Russia, China, and India. 42. The moon has been the subject of scientific study, with research into its geology, composition, and potential for supporting human exploration. 43. The moon's tidal forces have a stabilizing effect on Earth's axial tilt, which contributes to the planet's climate stability. 44. The moon has a weak magnetic field, which is thought to be a remnant from its early history. 45. The moon's gravitational pull has a small effect on Earth's rotation, gradually slowing it down over time. 46. The moon's appearance changes due to the angle of sunlight hitting its surface and the Earth's changing position in its orbit. 47. The moon's phases were instrumental in developing the concept of calendars and timekeeping. 48. The moon's gravitational interaction with Earth causes the planet's rotation to gradually slow down and the moon's orbit to slowly move away from Earth. 49. The moon's surface has highlands and lowlands, with the highlands containing many impact craters and the lowlands covered in smooth, dark lava plains. 50. The moon's surface has been mapped in detail by various lunar missions, providing valuable data for scientific research. 51. The moon's low gravity allows astronauts to make long jumps and carry heavy equipment with relative ease. 52. The moon's lack of atmosphere means that there is no protection from space radiation, making it a challenging environment for extended human habitation. 53. The moon's bright appearance is due to sunlight reflecting off its surface, while its dark patches, Maria, are areas of solidified lava flows. 54. The moon's rotational axis is tilted, resulting in different parts of its surface receiving varying amounts of sunlight over the course of a lunar day. 55. The moon's surface experiences extreme temperature variations between day and night due to its lack of atmosphere to retain heat. 56. The moon's low gravity has led to the formation of unique features called bouncing boulders, where rocks dislodged by impacts can travel long distances before coming to a stop. 57. The moon's surface has been scarred by impacts from meteoroids, asteroids, and comets over billions of years. 58. The moon's elliptical orbit causes variations in its distance from Earth, leading to changes in its apparent size and brightness in the sky. 59. The moon's surface is covered with a layer of dust and loose material, which makes it challenging to walk on and creates difficulties for exploration. 60. The moon's surface has been used as a natural laboratory for studying the effects of microgravity in space environment on materials and biological organisms. 61. The moon's gravitational pull has influenced Earth's climate and the distribution of oceans and continents over geological time scales. 62. The moon's lack of atmosphere makes it an excellent location for astronomical observations, as there is no distortion or absorption of light. 63. The moon's surface is marked by rays radiating from some craters, caused by material ejected during impact events. 64. The moon's gravitational interaction with Earth produces a slight wobble in the planet's rotation axis over long time scales, known as axial precession. 65. The moon's surface has been studied using remote sensing techniques, such as radar and spectroscopy, to analyze its composition and geological features. 66. The moon's gravity has been used for gravity assist maneuvers by spacecraft traveling to other destinations in the solar system. 67. The moon's phases were used by ancient civilizations to track the passage of time and mark the changing seasons. 68. The moon's origin is thought to be the result of a collision between a Mars-sized body and Earth, leading to the formation of a debris disk that eventually coalesced into the moon. 69. The moon's lack of a substantial atmosphere means that there is no protection from solar and cosmic radiation, making it a challenging environment for human exploration. 70. The moon's surface has been impacted by a range of objects, from small meteoroids to large asteroids, resulting in craters of various sizes. 71. The moon's surface contains various minerals and elements, including oxygen, silicon, aluminum, iron, calcium, and magnesium. 72. The Moon's gravitational interactions with Earth create tides in the planet's oceans, leading to the rise and fall of sea levels. 73. The Moon's surface has a low albedo, which means it reflects only a small portion of the sunlight that strikes it. 74. The Moon's surface is constantly bombarded by micrometeoroids and space dust, which contribute to the formation of its regolith. 75. The Moon's low gravity has allowed for the development of lunar rovers and exploration vehicles capable of traversing its surface. 76. The Moon's surface has unique features such as rills, which are long, winding depressions that may have been formed by ancient lava flows. 77. The Moon's gravitational pull affects the stability of Earth's axial tilt, which in turn influences the planet's climate and weather patterns. 78. The Moon's lack of a magnetic field has allowed scientists to study its ancient history by examining the preserved records of solar and cosmic radiation in its rocks. 79. The Moon's phases are caused by its changing position relative to the Sun and Earth, resulting in the varying amounts of its illuminated half visible from Earth. 80. The Moon's gravitational influence on Earth's tides has had a significant impact on the evolution of life in the oceans. 81. The Moon's surface has been used as a testbed for developing technologies and conducting scientific experiments related to space exploration. 82. The Moon's surface contains a variety of impact craters, including ones of different sizes and ages, providing insights into the history of the solar system. 83. The Moon's gravitational pull on Earth creates tidal bulges in the planet's oceans, resulting in the familiar rise and fall of tides. 84. The Moon's regolith has been used as a potential resource for future space exploration, including the extraction of water ice and other valuable materials. 85. The Moon's appearance changes as its position relative to the Sun and Earth shifts, resulting in its distinctive phases from new moon to full moon and back. 86. The Moon's gravitational pull affects Earth's rotation, causing the planet's rotational axis to precess over time. 87. The Moon's surface has been used as a subject of artistic inspiration, featuring prominently in literature, poetry, music, and visual arts. 88. The Moon's appearance in the night sky has been a source of wonder, curiosity, and contemplation for humans throughout history. 89. The Moon's gravity interacts with Earth's oceans, leading to the rise and fall of tides and influencing ocean currents. 90. The Moon's surface has been the focus of numerous scientific missions, including flybys, orbiters, landers, and sample return missions. 91. The Moon's lack of atmosphere means that there is no protection from meteoroid impacts, resulting in a heavily cratered surface. 92. The Moon's surface has been mapped and studied in detail using a variety of instruments, including telescopes, spacecraft, and robotic rovers. 93. The Moon's gravitational influence on Earth's tides has shaped the behavior of coastal ecosystems and marine life. 94. The Moon's impact craters come in various sizes, from small pockmarks to large basins, revealing a history of intense bombardment in the early solar system. 95. The Moon's surface has been used as a reference point for navigation and celestial observation by sailors, explorers, and ancient civilizations. 96. The Moon's gravitational pull on Earth affects the planet's rotation rate and axis, leading to changes in the length of days and seasons over geological timescales. 97. The Moon's phases are a result of the changing position of the Sun, Moon, and Earth relative to each other, resulting in the varying illumination of the lunar surface. 98. The Moon's surface has been visited by a range of robotic missions, including orbiters that have studied its composition, topography, and geology. 99. The Moon's gravitational pull on Earth has a stabilizing effect on the planet's axial tilt, preventing extreme changes in climate and temperature. 100. The Moon's phases have been a source of cultural and religious significance, influencing calendars, festivals, and rituals in different societies around the world. 1. Earth is the third planet from the Sun in our solar system. 2. Its distance from the Sun is about 93 million miles, 150 million kilometers. 3. Earth is the only known planet to support life. 4. The planet's diameter is approximately 7,917.5 miles, 12,742 kilometers. 5. Earth's surface is about 71% water and 29% land. 6. The highest point on Earth is Mount Everest in the Himalayas, reaching 29,032 feet, 8,849 meters, above sea level. 7. The lowest point on Earth is the Challenger Deep in the Mariana Trench, about 36,070 feet, 10,994 meters, below sea level. 8. Earth's atmosphere is primarily composed of nitrogen, 78%, and oxygen, 21%. 9. The planet has a magnetic field that helps protect it from harmful solar radiation. 10. Earth's rotation causes day and night, completing one rotation roughly every 24 hours. 11. It takes Earth about 365.25 days to complete one orbit around the Sun, resulting in a year. 12. The Earth's axial tilt is about 23.5 degrees, which causes the changing seasons. 13. Earth's moon is its only natural satellite. 14. The moon's gravitational pull causes ocean tides on Earth. 15. Earth's surface is divided into several tectonic plates that move and interact, leading to earthquakes and volcanic activity. 16. The largest ocean on Earth is the Pacific Ocean. 17. The deepest known point in the ocean is the Challenger Deep in the Mariana Trench. 18. The Earth's atmosphere consists of several layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. 19. The ozone layer in the stratosphere helps protect life on Earth by absorbing harmful ultraviolet (UV) radiation. 20. Earth has a diverse range of ecosystems, including forests, grasslands, deserts, oceans, and freshwater habitats. 21. The planet supports a vast variety of plant and animal species, many of which are still undiscovered. 22. Earth's core consists of a solid inner core and a liquid outer core, composed mainly of iron and nickel. 23. Earthquakes occur when stress along tectonic plate boundaries is released suddenly, causing ground shaking. 24. The Earth's continents were once part of a supercontinent called Pangaea. 25. The movement of tectonic plates has led to the formation of continents, mountains, and ocean basins. 26. The Amazon rainforest is one of the world's largest and most biodiverse rainforests. 27. The Great Barrier Reef is the world's largest coral reef system, located off the coast of Australia. 28. Earth's water is constantly cycling through processes like evaporation, condensation, and precipitation. 29. About 97.5% of Earth's water is found in the oceans, with only a small percentage available as freshwater. 30. The Earth's ozone layer is crucial for shielding life from harmful solar ultraviolet radiation. 31. Earth's climate is influenced by factors such as the sun, greenhouse gases, and ocean currents. 32. The greenhouse effect helps keep Earth's surface warm enough to support life. 33. The atmosphere contains greenhouse gases like carbon dioxide, methane, and water vapor. 34. Humans have significantly increased levels of greenhouse gases through activities like burning fossil fuels. 35. Earth's polar ice caps and glaciers store a substantial amount of the planet's freshwater. 36. The Antarctic ice sheet is the largest single mass of ice on Earth. 37. The Sahara Desert is the largest hot desert in the world, covering parts of North Africa. 38. Earth's axial precession causes a gradual change in the direction of its rotational axis over a period of about 26,000 years. 39. The International Date Line, located in the Pacific Ocean, marks where each new calendar day begins. 40. Earth's magnetic poles are not fixed and can shift over time due to changes in the planet's core. 41. The concept of Earth as a sphere was proposed by ancient Greek philosophers, such as Pythagoras and Aristotle. 42. Earth's moon plays a role in stabilizing its axial tilt and thus the stability of its climate. 43. Earth's geology provides insights into the planet's history and the processes that have shaped it over billions of years. 44. Fossils and rock layers reveal the history of life on Earth and its evolution over time. 45. Earth's water supports a diverse range of aquatic life, from microscopic plankton to massive whales. 46. The Earth's crust is divided into several major tectonic plates, including the Pacific Plate, North American Plate, and Eurasian Plate. 47. Earth's rotation causes the Coriolis effect, which influences the direction of winds and ocean currents. 48. The atmosphere is divided into distinct layers, each with its own unique characteristics and functions. 49. Earth's magnetosphere protects the planet from the solar wind and charged particles emitted by the sun. 50. Earth's continents are in constant motion, moving at rates of a few centimeters per year. 51. The North Pole and South Pole are the points where Earth's rotational axis intersects its surface. 52. Earth's magnetosphere interacts with solar wind to create auroras, also known as the northern and southern lights. 53. The Earth's oceans play a vital role in regulating the planet's temperature and climate. 54. The Dead Sea, located between Israel and Jordan, is one of the saltiest bodies of water on Earth. 55. Earth's diverse climates range from tropical rainforests to arid deserts and frigid polar regions. 56. The planet's diverse geological features include mountains, valleys, canyons, and plains. 57. Earth's lithosphere is composed of rigid tectonic plates that float on the semi-fluid asthenosphere beneath them. 58. The Great Lakes in North America contain about 20% of the Earth's freshwater. 59. Earth's oceans contain an estimated 20 million tons of gold dissolved in seawater. 60. The Earth's rotation causes the equator to bulge slightly, making the planet slightly oblate, flattened at the poles. 61. Earth's ozone layer is primarily located in the stratosphere and absorbs most of the sun's harmful UVB and UVC radiation. 62. The Pacific Ring of Fire is an area in the Pacific Ocean known for its high levels of seismic and volcanic activity. 63. Earth's inner core is solid due to high pressure, even though its temperature is higher than the melting point of iron. 64. Earth's magnetic field is generated by the motion of molten iron in its outer core. 65. The Earth's atmosphere becomes thinner with increasing altitude, eventually merging into space. 66. The Earth's rotation is gradually slowing down due to tidal forces caused by the Moon's gravitational pull. 67. Earth's oldest rocks date back about 4 billion years, providing clues about the planet's early history. 68. The largest desert on Earth, in terms of area, is Antarctica. 69. The Earth's rotation causes the Coriolis effect, which affects the direction of moving objects on the surface. 70. The Earth's outer core is responsible for generating the planet's magnetic field through a process called the geodynamo. 71. Earth's diverse ecosystems provide habitats for countless species, from microscopic organisms to large mammals. 72. The Earth's rotation causes the polar regions to experience continuous daylight during certain times of the year, polar day, and continuous darkness during other times, polar night. 73. The Earth's atmosphere consists of different layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. 74. The Earth's magnetic field protects the planet from harmful solar radiation, preventing it from stripping away the atmosphere. 75. Earth's climate has undergone significant changes throughout its history, including ice ages and periods of warmth. 76. The Earth's surface experiences erosion and weathering due to processes like wind, water, and temperature changes. 77. The Earth's oceans contain an estimated 97% of the planet's water, with the remaining 3% being freshwater found in glaciers, lakes, and rivers. 78. The Earth's gravitational pull is slightly stronger at the poles than at the equator due to its oblate shape. 79. Earth's rotation causes the Coriolis effect, which influences the direction of moving air masses and ocean currents. 80. Earth's surface is divided into several major tectonic plates, including the African Plate, South American Plate, and Indo-Australian Plate. 81. The Earth's crust is relatively thin compared to the planet's overall size, and it is composed of solid rock. 82. Earth's atmosphere plays a vital role in regulating temperature and distributing heat around the planet. 83. The Earth's lithosphere is divided into continents and ocean basins, each with unique geological features. 84. Earth's diverse landscapes include mountains, valleys, deserts, forests, and coastal areas. 85. The Earth's oceans contain a wide variety of marine life, from microscopic plankton to massive whales. 86. Earth's magnetic field is generated by the movement of molten iron in the outer core, creating a protective shield against solar wind. 87. The Earth's atmosphere is composed mainly of nitrogen, about 78%, and oxygen, about 21%. 88. Earth's rotation causes the phenomenon of day and night, as well as the apparent motion of the sun across the sky. 89. The Earth's axial tilt is responsible for the changing seasons as different parts of the planet receive varying amounts of sunlight throughout the year. 90. Earth's geological features, such as mountains and valleys, are shaped by processes like erosion, tectonic activity, and weathering. 91. The Earth's atmosphere contains trace amounts of various gases, including carbon dioxide, methane, and water vapor. 92. Earth's oceans play a crucial role in regulating the planet's temperature by absorbing and distributing heat. 93. The Earth's climate system is influenced by factors such as the sun, greenhouse gases, ocean currents, and atmospheric circulation. 94. Earth's geological history is preserved in layers of sedimentary rock, providing insights into the planet's past. 95. The Earth's magnetosphere protects the planet from the solar wind, preventing it from stripping away the atmosphere and water. 96. Earth's magnetic field is not aligned with its rotational axis and undergoes periodic reversals. 97. The Earth's tides are caused by the gravitational pull of the Moon and, to a lesser extent, the Sun. 98. Earth's oceans contain a wide variety of ecosystems, from shallow coral reefs to deep-sea trenches. 99. The Earth's rotation causes the equator to bulge, resulting in a slightly flattened shape known as an oblate spheroid. 100. Earth's geological processes, such as plate tectonics and volcanic activity, have shaped its surface over billions of years. 101. These facts provide a comprehensive overview of Earth, covering its composition, physical characteristics, geological processes, climate, and its significance as the only known planet with life. Thanks for watching. Please like and subscribe and share.